Hello and welcome dear student in the next video lecture of the topic solid state. So dear student, in the last lecture we have started a sub point in the solid state, that is a defect or imperfections in the crystals. In that we have seen what is meant by defect. Defect is produced when the rate of crystallization is faster than the requirement. The defect in a crystal structure is produced when the rate of crystallization during the crystallization, that means during the crystallization there is some imperfections or fault in the arrangement of the lattice points, and therefore that fault in the arrangement of the crystal structure is called as a defects. So in the type of defect there are three types of defects: point defect, line defect and a plane defect. But in our topic solid state we have to study only a point defect in details. So in that we have completed the point defect, what is meant by point defect and what is the classification of the point defect. The point defect is arises when there is irregularities in the arrangement of the particles in the crystal structure, and a point defect are classified into the three main types: stichomatric defect, non-stichomatric defect and the impurity defect. The point defect are classified into the three types: stichomatric defect, non-stichomatric defect and a impurity defect. And in that further we have completed the type of a stichomatric defect. The stichomatric defect, they are having a type, that means a vacancy defects, self-interstitial defects, Schottky defects and Frankel defects. All these points we have covered in detail in our last lecture. So dear student, here we are continue to the second type of a point defect, is called as here a impurity defect. So in this lecture we are going to start the second type of a defect. The second type of a defect is called as a impurity defect, and that defect and the non-stichomatric defect we are going to study in detail in this video lecture. So let us start with the impurity defect. So first of all we have to come know about the what is meant by impurity defect. An impurity defect is arises when a new atom, that means a foreign atom, they are replaced by the host atom. Because suppose this is the entire crystal structure and these are the atoms or the sites which are already present in that crystal structure, and therefore if these particles of the crystal structure, if they are replaced by a new atom, these particles are called as a host atom, or these atoms are called as a host atom. And if the foreign, that means a new atoms, when they enters in the crystal structure instead of the host, means the original atom, then the impurity defect it would be arises. That means here the impurity defect is arises when the foreign atom, that means the atoms different than the host atom, is enter in the crystal structure. So the impurity defect is the second type of a point defect, and they are further classified into the two types. The first one is substitutional impurity defects and the second one is interstitial impurity defects. The impurity defects are classified into the two types: substitutional impurity defects and the interstitial impurity defect. In substitutional impurity defects, here we have two examples of these substitutional impurity defects, in which the first one is, for example, a brass. Brass, it is an alloy of the metal copper and zinc. Brass, it is an alloy of a metal copper and zinc. In brass, when the host atom is the copper atom, means in a brass the main content of the brass is the copper. That means a copper which is present in the maximum amount. And if we add, why we add the zinc in the copper? To increase their properties, to increase the properties of the metals alloy. मेटल alloyच्या प्रॉपर्टी वाढवण्यासाठी आपण काय करतो? कॉपर मध्ये थोडासा काय ऍड करतो? झिंक ऍड करतो. Here the copper is the host metal and the zinc is impurity. The zinc which is acts as an impurity, when a small amount of zinc is added in a copper metal, then a brass is formed. That means instead of copper in these sites or in some sites, if we replace the copper by the zinc, then this is called as a substitutional impurity defects. That means here in a substitutional impurity defect, a brass is an alloy of a copper and zinc, and therefore in a brass the host copper atom are replaced by the impurity, because here the zinc which acts as an impurity, then the zinc occupies the regular sites of a copper atom. Here the zinc which occupies, these are the regular sites of the copper atom, but the some sites of the copper, when they are occupied by the zinc, then it is called as a substitutional, because the zinc is substituted instead of a copper, because here the zinc which acts as an impurity, and therefore it is called as a substitutional impurity defects. And the example of this is a brass. The another example of this substitutional impurity defect is the vacancy through the alloy valent impurity. In this vacancy through alloy valent impurities, here in this, the second example of the substitutional impurity defect is the vacancy through alloy valent impurities. The first one is a brass. In brass, impurity like zinc is added with a copper metal, and therefore the defect produced is called as a substitutional impurity defect. In these substitutional impurity defects, here the vacancy through alloy valent impurity, that means the vacancies are produced in the crystal structure here when an alloy valent ions means what? When here the impurity, or here we add the impurities of alloy valent ions. Alloy valent ions means what? The ions with the higher oxidation state than the oxidation state which is produced by these ionic solids. Means these ionic solid which is a NaCl solid. In this ionic solid, here the plus charges means they are all the Na plus, and the Cl minus means the minus charges. In this ionic solid, this is the ionic crystal of the NaCl. This is the ionic crystal of the NaCl. And if we add the alloy valent ion means the ions which is having the higher oxidation state than the Na plus, because Na plus is the host atom. Cl minus is the host atom of this crystal structure. In this crystal structure, Na plus and Cl minus are the host atoms which is represented here. But if we add the alloy valent ion in these crystal, then what happened? The vacancies are produced. The vacancies are produced. And how the vacancies are produced? So, in NaCl crystal, if we add some small amount of SrCl2, SrCl2 means strontium chloride, and the strontium chloride produces the ions like Sr2 plus 2Cl minus. Here a small amount of impurity like SrCl2 which is added in this NaCl crystal. Then the Sr2 plus, here the Sr2 plus occupies the position of the positively charged Na plus. But the Na having only one charge and Sr having 2 plus charge. To maintain the electrical neutrality here for Sr2 plus ion, because here instead of Na, the impurity of Sr2 plus is added in this NaCl crystal, but the Sr they are having a 2 plus charge. That means this is the allovalent ion having oxidation state other than the Na plus. Na plus having plus 1 oxidation state. Sr2 plus having plus 2 oxidation state, and therefore if you adding the Sr2 plus as impurity in this, then they create a vacancy. Why they create a vacancy? Because instead of the here one Na plus, here Sr2 plus are inserted, and if we insert the Sr2 plus, then it creates a vacancy. Why it create a vacancy? Because for one Sr here we remove the 2 Na plus, because the Sr having a 2 plus charge, Na having a 1 plus charge, and therefore here instead of Na plus here we have Sr2 plus, but they are having a plus 2 charge, and therefore another Na plus it get removed, and therefore this is the impurity like Sr2 plus when added to the NaCl original crystal, the host atom, it is replaced by that impurity, but here a vacancy is created because here allovalent ions means the ions they are having a higher oxidation state than the host atom, and therefore this is the vacancy through allovalent impurities. And in this defect here we have considered the vacancies are created by the additions of impurity of allovalent ions, and therefore in order to maintain the neutrality, every Sr2 plus ions removed 2 Na plus ions, म्हणजे एका Sr2 plus ions ला 2 Na plus ions निघून जाणार आहे. का? To maintain the electrical neutrality. So because this is the stichometric effect, means in a point defect, these are stichometric defects. Stichometric defects are classified into the 3 types. Sorry, these are the impurity defects, and therefore in these impurity defects here we have 2 types. In that, the first one is the substitutional impurity defect, and in that we have seen the 2 examples. The first one example is the example of brass, and the second one example is the vacancy through allovalent impurity. Then next, this is the second type of point defect. Then next to that we have discussed the third type of point defect is non-stichometric defect. So in a non-stichometric defect here, but before going to start the third type of a point defect, here we have a second type of a impurity defect, that means interstitial impurity defect. Because as we know, the impurity defect are classified into 2 types. The first one is substitutional impurity defect, and in that we have seen the 2 examples. First one is a brass, and second one is the vacancy through allovalent impurity. Then the second type of impurity defect is interstitial impurity defect. The interstitial impurity, this is an example of the interstitial impurity defect. This is the regular crystal structure, and the interstitial impurity defect arises when an atom occupies an interstitial site of the regular crystal structure. The interstitial defect means an impurity atom and impurities they occupies the interstitial interstitial site in that crystal structure. For example, SS. What is mean by SS? SS means a stainless steel. A stainless steel, it is an alloy of Fe, Cu, Ni and Cr. But the Fe are present in the more amount in the stainless steel, and in that stainless steel these are the regular sites of the Fe, means the iron atom, and an impurity of a carbon. An impurity of a carbon is occupies an interstitial sites in that Fe, and therefore this type of defect is called as a interstitial impurity defect. That means in interstitial impurity defect, the impurity atom occupies the interstitial site. For example, in stainless steel, here the carbon which is present or which occupies the interstitial site in the stainless steel. So this is our second type of a defect called as a impurity defect. Then next, the third type of a point defect is non-stichomatric defect. That part we have discussed here. The third type of a defect is a non-stichomatric defect. That means the third type of a defect of the point defect is a non-stichomatric defect. A non-stichomatric defect means what? A non-stichomatric defect arises when the ratio of number of cation to the number of anions are different than those in the crystal structure of the chemical formula arises. Means here in the crystal structure, the number of cations and the number of anions ratio is different in this non-stichomatric defect. But further there it is important to there is no change, means if the stichometry is changed, then it does not cause any change in the crystal structure. In short, the stichometry change means the stichometry of the compound, it gets changed in the non-stichometry means stichometry. Stichometry means the number of positively charged ions and the number of negatively charged ions, they are having a different ratio. The ratio of cation to the anion, it gets changed in the non-stichomatric defect. But still there is no cause any change in the crystal structure, and therefore a non-stichomatric defect, they are classified into the two main types. The first one is metal deficient defect and the second one is metal excess defect. In that, here first we have discussed the metal deficient defect first. So this is an example for the metal deficient defect. This is a crystal structure of NiO, nickel oxide. Means here all the positive charges means the all Ni2 plus and the negative charges are the O2 minus, because this is the crystal structure of the NiO. But this metal deficient defect arises here when there is a possible of this defect only in a compound of a metal that shows the variable oxidation state. Means this metal deficient defect is possible only in that compound in which they shows the variable oxidation state. That means here in this compound Ni, it shows the two variable oxidation state, Ni2 plus and Ni3 plus. And this metal deficient defect is shows only by those metal compound which shows the variable oxidation state. Then what happened in this metal deficient defect? Consider this NiO crystal structure, means all the positive charges means all Ni2 plus and the negative charges are the O2 minus. But here if we replace here in this compound Ni2 plus ions are missing, created a valency. Here one of the Ni2 plus ions is missing and it creates a valency. Why? Because here we have the Ni having the two oxidation states +2 and +3. That means instead of here, if we having Ni3 plus and here also we having Ni3 plus, and due to maintain the electrical neutrality, because all the Ni they are having a +2 charge, and in the metal deficient, here a divalent Ni is replaced by a trivalent Ni. Means Ni having two possible oxidation state +2 and +3, and therefore a one vacancy is created for 2 Ni3 plus ions. That means here what happened in the compound of NiO, one Ni2 plus ions is missing, created a vacancy as shown in that figure. So this deficiency of a two positively charges is made up by the presence of the two Ni3 plus ions at the same lattice of the Ni2 plus ions. So the composition of Ni2 plus ions become here Ni0, 97 and O1. That means here what happens in the metal deficient defect, the Ni they shows the variable oxidation state +2 and +3, and therefore the +2 it becomes a vacant when the Ni2 plus is replaced by the Ni3 plus, and for 2 Ni3 plus here we have a vacancy of 1 Ni2 plus due to maintain the electrical neutrality in this non-stoichiometric defect, because here Ni2 plus, Ni3 plus means Ni6 plus, and here one Ni it get replaced or it create a vacancy. So this is the second, the first type of non-stoichiometric defect is a metal deficient defect. The second type of a non-stoichiometric defect is a metal excess defect, and in that metal excess defect consider, that means a metal excess defect they are of two types. The metal excess defect they are of two types. In first type here a neutral metal atom, or here an extra positive ion occupies the interstitial position, but they are carried in the two ways. First one here a neutral zinc, because this is the crystal sites of the ZnO, and as we know ZnO is means Zn2 plus and a O minus. So in ZnO the minus means minus means O2 minus and plus means Zn2 plus. These are the crystal structure of a ZnO. In metal excess defects, as I told you, it is classified into the two types. In first, a neutral metal atom, that means an excess Zn which is a neutral in nature, when it is added in that crystal structure, then it forms a metal excess defect. It forms a metal excess defect. Or secondly, if we heated this metal crystal, this crystal structure, then this Zn is present in the form of Zn2 plus. That means when we heated this ZnO, if we heated this ZnO, then it forms Zn2 plus half O2 plus the two electrons are released here. Here in the metal excess defect, an excess metal occupies the interstitial position, or that crystal when they get decomposed, then it forms just like that. It forms the Zn2 plus ions, and the electrons they can be moved in that crystal structure. That will be the metal excess defect. First type of metal defect excess or the metal excess defect, that means we add an extra atom as in that of the atom or the host atom, and it is get excess, or when that metal crystal is heated, then it forms an ion of that particular metal, and the electron they will be get released. So this is the first type of metal excess defect. The second type is by anionic vacancies. The second type of metal excess defect is anionic vacancies. Then what is mean by that anionic vacancies? And for that consider the NaCl crystal. The second type of metal excess defect is the by anionic vacancies. That means consider this NaCl crystal, and when this NaCl crystal is heated in presence of a sodium vapor, then the sodium atom are deposited on the crystal structure, or the sodium metal is only deposited by a crystal surface. Means in this sodium chloride crystal, if we heated this sodium chloride crystal in presence of a sodium vapor, then the sodium atom here, the sodium atoms are deposited on the surface of a crystal, and therefore the Cl minus ions diffuses to crystal surface containing vacancies. Here, if the sodium atom is deposited on the surface of a metal surface, and therefore the Cl minus ions diffuses to the crystal. Here the Cl minus ions is present, but it gets deposited because the sodium atom is get deposited on the surface of a metal or on the surface of this crystal structure. The Cl minus ions it get diffuses, and therefore they create a vacancies to their regular side, because here the Cl minus are present, but due to the here the sodium atom are deposited on the crystal structure, the Cl minus ions diffuses to the crystal structure and produces a vacancy due to the Cl minus, and these are the ion, and therefore it is called as a anionic vacancy. This is called as a anionic vacancies. So the Cl minus ions combines with the sodium. Here the sodium metal is deposited, and therefore the sodium is deposited. It combines with the Cl minus ions, and it produces the NaCl plus. The electrons it will be get released. Here the electrons are present. The electrons it will be released, and therefore they are to form a NaCl by releasing the electron from the sodium atom. The electron released diffuse into the crystal and occupies the vacant site of anions, the released electrons, because in these by anionic vacancy metal excess defect, when the sodium chloride crystal is heated in presence of the sodium vapor, the sodium atom is deposited, and therefore the atom, when they react with the Cl minus which is present in that crystal structure, they form the NaCl, and the electron it will be get released, and the released electron they replaces, or they are in place of the anions, and therefore here the anion vacant side occupies by electrons are F centers. The anions here occupies the anion vacant sites occupies by the electrons are F centers. They are called as F centers because here the anions are missing, and instead of that anions we have an electron here, and therefore they are called as F centered. And this type of a defect imparts the color to the colorless crystal, and due to that F centers a color is get colorless to the crystal. म्हणजे जर त्या क्रिस्टलचा कुठला कलर असेल तर त्याचा कलर काय होतो, बदलतो, आणि ते क्रिस्टल कलरलेस येतं ड्यू टू दिस F centers. F centers means the anions they are replaced by the electrons. So dear student, these are the types of defects. The defects are classified into the three types. The first one is a point defect, line defect and a plane defect. In that, only the point defect we have considered here, and in that we have a stichometric defect, non-stichometric defect and impurity defect. The stichometric defect are classified into the four types: vacancy defect, self-interstitial defect, Schottky defect and Frankel defect. That part we have completed in our last lecture. So in today's lecture, what we have to done, the second type of defect is a impurity defect. In that, again they are classified into two types: interstitial impurity defect and the substitutional impurity defect. And the third type of a defect is called as a non-stichometric defect. The non-stichometric defect are also further classified into the two types: metal deficient defect and a metal excess defect. So all these are the classification of the defects. So here we have completed these subpoints, that means the classification of the defect. So in today's lecture we will stop here. We will meet in the next lecture. Till then, thank you.